Hello everyone, my name is Anshurina Campo, the first presenter of Group 4. Our topic is about correlation and regression, another area of inferential statistics that involves determining whether a relationship exists between two or more numerical or quantitative variables. Correlation is a statistical method used to determine whether a relationship between variables exists, and regression is a statistical method used to describe the nature of relationship between variables, positive or negative, linear or nonlinear. The purpose of this chapter is to answer these questions statistically. 1. Are two or more variables related? 2. If so, what is the strength of the relationship? 3. What type of relationship exists? 4. What kind of predictions can be made from the relationship? To answer the first two questions, if two or more variables are related and what is the strength of the relationship, we have a scatter plot and correlation. A scatter plot is a graph of the ordered pairs of numbers consisting of the independent variable x and the dependent variable y. In a simple correlation and regression studies, the researcher collects data on two numerical or quantitative variables to see whether a relationship exists between the variables. For example, if a researcher wishes to see whether there is a relationship between the hours of study and test scores on an exam, she must select a random sample of students, determine the hours each studied, and obtain their grades on the exam. A table can be made for the data as shown. On the first row, we have the student A, B, C, D, E, and F. On the second row, we have the number of hours studied, and on the last row, we have their grades. An independent variable is the variable in regression that can be controlled or manipulated. In this case, the number of hours of study is the independent variable and is designated as the x variable. The dependent variable is the variable in regression that cannot be controlled or manipulated. The grade the students receive on an exam is the dependent variable designated as the y variable. The determination of x and y variables is not always clear-cut and is sometimes an arbitrary decision. For example, if a researcher studies the effects of age on a person's blood pressure, the researcher can generally assume that age affects blood pressure. Hence, the variable age can be called the independent variable, and the variable blood pressure can be called the dependent variable. On the other hand, if a researcher is studying the attitudes of husbands on a certain issue and the attitudes of their wives on the same issue, it is difficult to say which variable is independent variable and which is the dependent variable. In this case, the researcher can arbitrarily designate the variables as independent and dependent. The independent and dependent variables can be plotted on a graph called a scatter plot. The independent variable x is plotted on a horizontal axis and the dependent variable y is plotted on the vertical axis. The procedure for drawing a scatter plot. Example, construct a scatter plot for the data shown for car rental companies in the United States for the recent years. As we can see, we have the data here. Step 1. Draw and label x and y axis. Step 2. Plot each point on the graph. After the plot is drawn, it should be analyzed to determine which type of relationship, if any, exists. We have three types of correlation. The first one is the positive correlation. A positive correlation is a relationship between two variables in which both variables move in the same direction. Therefore, when one variable increases as the other variable increases, or one variable decreases while the other decreases. An example of positive correlation will be height and weight. Taller people tend to be heavier. Another one is a negative correlation. A negative correlation is a relationship between two variables in which an increase in one variable is associated with a decrease in the other. An example of negative correlation will be height above sea level and temperature. As you climb the mountain, it gets colder. The last one is the zero correlation. A zero correlation exists when there is no relationship between two variables. For example, there is no relationship between the amount of tea drunk and level of intelligence. This graph shows a positive relationship. The plot of the data shows a positive relationship since as the number of cars rented increases, revenue tends to increase also. Another example, construct a scatter plot for the data obtained in the study on the number of absences and the final grade of 7 randomly selected students from a statistics class. Step 1. Draw and label x and y axis. Step 2. Plot each point on the graph. As we can see, the plot of the data shows a negative relationship, since as the number of absences increases, the final grade decreases. For our last example, construct a scatter plot for the data obtained in the study on the number of hours of the 9 people exercise each week and the amount of milk in ounces each person consumes per week. The data are shown. Step 1. Draw and label x and y axis. Step 2. Plot each point on the graph. As we observe, the plot of the data shows no specific type of relationship, since no pattern is discernible. In the next topic, which is correlation coefficient, we will determine the strength of this relationship. That's all for scatter plot. Thank you for listening.